Welcome back to SS2 Physics. This week we study the behavior of gases under changing conditions of pressure, volume, and temperature. Gas laws describe mathematical relationships that govern how gases respond to changes in their environment. These principles are used in tire pressure management, medical ventilators, weather balloons, and industrial refrigeration. By the end of this lesson, you will be able to state and apply Boyle's law, Charles's law, and the combined gas law. You will solve quantitative problems and understand the conditions under which each law applies. We assume ideal gas behavior throughout, meaning we treat gas molecules as having negligible volume and no intermolecular forces. Let us begin. Boyle's law, formulated by Robert Boyle in 1662, states that at constant temperature, the pressure of a fixed mass of gas is inversely proportional to its volume. In mathematical form, P times V equals a constant. Or P1 times V1 equals P2 times V2, at constant temperature T. If pressure doubles, volume halves. Think of squeezing a balloon. As you reduce the volume, pressure inside increases. Example, a gas occupies 4 liters at 2 atmospheres pressure. What volume does it occupy at 8 atmospheres, temperature remaining constant? Using P1 V1 equals P2 V2, 2 times 4 equals 8 times V2. V2 equals 8 divided by 8 equals 1 liter. The volume reduces from 4 liters to 1 liter. Now, Charles's law, proposed by Jacques Charles in 1787, states that at constant pressure, the volume of a fixed mass of gas is directly proportional to its absolute temperature. Formula, V divided by T equals a constant. Or, V1 divided by T1 equals V2 divided by T2, at constant pressure P. Crucially, temperature must be in Kelvin. To convert Celsius to Kelvin, add 273. So 27 degrees Celsius equals 300 K. Example, a gas has volume 3 liters at 27 degrees Celsius. What is its volume at 127 degrees Celsius at the same pressure? T1 equals 300 K. T2 equals 400 K, V2 equals V1 times T2 divided by T1 equals 3 times 400 divided by 300 equals 4 liters. The combined gas law merges Boyle's and Charles's laws into one equation that applies when both pressure and temperature change simultaneously. Formula P1 V1 divided by T1 equals P2 V2 divided by T2. This is the most useful equation in WAEC gas law questions. Example, a gas occupies 500 cubic centimeters at 27 degrees Celsius and 1.0 times 10 to the power 5 pascals. Find its volume at 127 degrees Celsius and 2.0 times 10 to the power 5 pascals. Convert temperatures. T1 equals 300 K, T2 equals 400 K. Using the combined law, V2 equals P1 V1 T2 divided by T2 P2. V2 equals 1.0 times 10 to 5 times 500 times 400 divided by 300 times 2.0 times 10 to 5. V2 equals 200 times 10 to 8 divided by 6.0 times 10 to 7. V2 equals approximately 333 cubic centimeters. This type of calculation appears regularly in WAEC. Note, standard temperature and pressure, or STP, is defined as 0 degrees Celsius, 273 K, and 1.01 times 10 to the power 5 pascals or 1 atmosphere. Many problems ask you to convert to STP. Let us summarize the 3 gas laws. Boyle's law, PV equals constant at fixed T, pressure and volume are inversely proportional. Charles's law, V divided by T equals constant at fixed P, volume and temperature are directly proportional, use Kelvin. Combined gas law, P1 V1 divided by T1 equals P2 V2 divided by T2. Applicable when both pressure and temperature change. Real-world applications, car tires, higher temperature on hot roads increases tire pressure, consistent with Charles's and Boyle's laws. Weather balloons, as they rise to lower pressure altitudes, they expand. Human lungs, during inhalation, lung volume increases and pressure drops below atmospheric, drawing air in. WAEC tip, Always convert Celsius to Kelvin before using Charles's or the combined gas law. Check your units: pressure in bar or atm, volume in cubic centimeter or cubic meter, but be consistent across P1V1/T1 and P2V2/T2.